All right, so let's go over assignment number 3. It's a continuation of assignment number 2, right? It asks you to take assignment number 2 and refactor the HTML into a dynamic Angular application, right? A starting point of making this instead of a website that navigates using legacy normal ways of navigating anchors referring to pages to other pages. We're going to refactor that into a single page application using Angularjs. One of the first couple of things I was going to ask you to do is to convert the static HTML that you currently have into an Angular application, and to declare the entry point of your application as the index, this index page. Right, there'll be an index page that this will be the only deliberate HTML page that will ever be loaded. Right, any other HTML that's going to be loaded is going to be done using asynchronous calls back to the server, calling these snippets of HTML and building the page dynamically by dynamically modifying the DOM by the Angular infrastructure. But the page will never ever reload again unless you deliberately reload it, right? Control-R. But even as you navigate from one page to the next, you're never actually going to leave this index page. You're only going to ever stay here. Okay? Hence the single page application philosophy. Yes?
Would the back functionality work then?
Meaning navigating back and forth? Yes. Yes. The functionality of navigation that we're going to introduce today uses the hash as a mechanism to be able to encode the state of the application, and the browsers include the hash. Any changes in the hash, it includes it in the history of the browser. So yeah, so the back button, forward buttons work just fine. Yep. Yeah, this used to be challenging. You know, when we used to do especially on server-side technology, this was challenging. We would, and this would be a caveat. We tell users, please don't use the back button. Right? No such problem here. So we are going to declare our application. The JavaScript's part of this, the logic, it's the entry point of the application will be in a file called app.js, where we're going to declare a module, top-level Angular module called WebAppMaker, which right now is not going to have any dependencies, but a little later we're going to add a couple of dependencies to be able to implement the navigational part of this, right? That allows you to navigate between the pages without ever leaving index.html. Okay. It's going to ask you to do some refactoring of the file system. Right now, most of your pages perhaps are all in a flat folder, right? And so that should start to concern you, right? As the project grows, and perhaps we might ask other folks to join the team. It's starting to get out of hand, right? It's starting to the number of artifacts that we need to manage is just getting out of hand. We have at least 9 HTML pages, right? Perhaps a couple of CSS files, and today, you know, we're going to start adding controllers to each one of these pages. So at least it's going to double in size, right? The number of artifacts that we have to deal with, and us being humans, we like to be able to organize and structure things into smaller chunks so that we can deal with these things. So one typical way that we do this is by creating abstractions, right? We create hierarchies where we have higher top-level hierarchies, and we have lower and lower and lower until we have, you know, the concrete. So we're going to create folders, right? So that it's going to allow us to group pages that are, you know, that naturally go together, right? So for instance, the login page, the profile page, the register page, they all deal with user, right? Logging in, registering. And so we're all going to grab all the user pages and we're going to put them under a user directory. Same thing for all the pages that manipulate websites, right? Website edit, website list, website new, All of them, we're going to group them under a directory called website. Same thing with pages, same thing with widgets, right? Again, creating a hierarchy of things so that we can then deal with them independently, right? And perhaps assign different developers to each one of these features, okay? And we're also going to be renaming some of these pages, some of these HTML documents. So instead of page list HTML or website list HTML, or we're going to start adding some meaning to these names. We're going to try and capture the roles, right? We're trying to capture some of the roles that each page plays in the application, right? Or where does it fit in the larger scheme of the overall application? So for instance, this naming convention says that this is a part of the view, right? So presumably this is something that is going to be consumed by a human being. It's going to be looking at this data, right? It's not going to be some JSON data. It's going to be something that looks pretty, meant for human consumption. Also, in the name we have the keyword client, right? And presumably this means that this is being rendered where? In the client. The client is rendering this. The browser is rendering it, not the server, right? As you would if this were PHP or JSPs or ASPs, those would be HTML that is generated dynamically on the server side, right? This is HTML that is dynamically generated on the client side, right? So this? It doesn't have to be this naming convention. I, as a project manager, decide that this is the naming convention. But in your teams, you would come up with whatever naming convention your team comes up with, right? Whatever works for the team. Right? But ideally, you would look at this file and immediately places you where you are or who's responsible for this, right? And that's very important when you're working with large projects, right? Lots of teams working together, and people start, the teams become familiar on how it's structured, and names help a lot. These conventions help a lot. Then all these directories, user, website, page, widgets, we're going to grab all those, and we're going to drop them all into a directory called views, right? Under views. The idea is that we're not just going to have artifacts for rendering things for the user. We're going to have other things, other types of artifacts, right? For instance, we're going to need controller artifacts that handle all the events that the user generates, right? As the user clicks and drags and moves and scrolls and interacts with the application, users are going to generate a stream of events, right? That we need to capture and interpret and then convert those into real actions that modify some data in the back end, yes? So those are going to be controllers, and they're going to live under a particular directory. We're going to move those as well. Also, we're going to need artifacts that go and talk to the database, right, or talk to the server that convert these streams of events, right, and sends them to a server through HTTP posts or puts or gets or deletes or whatnot, right? In a particular URL encoded message, and the server is going to respond. Yes. So those are going to be artifacts that we're going to call services, right? That are going to be talking to RESTful services and API in the back end. So those are we're going to create those, and we're going to put them in all together under a directory called services. So up to this point, we have views. We have views, right? We have services, right? And the controllers, one popular place to put the controllers are in a directory called controllers, okay? And here are a couple of competing ways of organizing the files. This would split all these different artifacts by the type of the artifact, right? So all the views would go under views, all the services, all the controls under each one of them, right? This is a fairly flat way to organize it. Another competing way to do this is by the feature, right? For instance, there's a user feature, there's a website feature, right? There's a page feature, right? Which we're kind of following here. In that organization, there are also a couple of different competing ways to do it. So for under user, you might have all the HTML that would go along with this, right? And perhaps even the controllers under here. Okay. Another competing way to organize this under user is again by type of artifacts, where you might have the templates under one directory where you would have all your HTML, right? And the controllers under a separate directory, the controllers under here, all the JavaScript that go along with those, right? Again, there's quite a few competing ways of organizing it. For now, we're gonna keep it simple, right? We're gonna keep all the HTML and the controllers under just the user directory, right? As these grow, again to handle the chaos, right? If this grows too much, right, it makes sense to break it up into separate directories, right? To deal with complexity, right? Okay, so we have under views, we're gonna move all the websites, the page, the user, the widget directories under the views, right? Also, all these HTML that we're moving in under all these directories, they're no longer going to be full-blown HTML documents. Okay, they're not going to be meant. They're not meant anymore to be visited and consumed independently from each other. Okay, they're all going to become just snippets of HTML. Right, they're going to be part of a larger framework. Right, that we're going to be loading these pieces, snippets of HTML, right, discretely, and building the page with these pieces of HTML, right. So we're going to start removing some of the common content, such as the HTML, the head, the meta, the title, all these links, right, that made sense when these were standalone HTML documents, right. But they're no longer going to be standalone HTML. They're going to be templates. Okay, so we're going to remove all those. So we're going to move. Probably most of these are going to be the same, right? It's going to be the same meta tags, the same links, the same scripts, right? The same. So if you grab any one of these that it's well representative of all the other HTML files, you can copy from any one of these, right? All these tags and just move them into the index page, right? The index page is going to be the single page that gets loaded, right? That loads all the other scripts, all the other libraries, right? All the styling. It's going to provide the head, the body, yes? And then all the other snippets of pages, right? All the other HTML templates are going to be injected into the index page dynamically using the Angular model view controller library. Okay? Make sense? Right. Then we're going to be modifying the routing mechanism. No longer is each page going to know about other pages, right? Just like the login page, for instance, knows about the profile page and knows about the register page, yes? And the register page knows about the profile page and the login page, right? So you have this, any particular page having hard-coded links to some other pages, right? And this is fine, right? This is how we normally implement navigation, right? And to exaggerate a little bit, what the problem with that is, right? Is that imagine you had any number of pages, right, that are referring to each other, right? Where you have page A referring, page B over here, and referring to page C over here, right? And then B referring to other pages down here. And then, after a while, again, I'm exaggerating, what you have is kind of like spaghetti code, right? Where you have all this, all the logic, all the navigation logic is spread across, quite a few number of artifacts, right? There's no one place that I can look at this. This is how is the navigation of this, right? Unless somebody draws it for me, right? There's no one place where I can see this, right? I would have to visit each page. Says, okay, from here, where do I go? Oh, I can go to these other two pages, right? Because that's where the logic lives in the page, right? Maintaining this in a small application, a small website, it's fine. But on larger applications that evolve over time as new requirements come in, that we need to perhaps we have this very popular page that is referenced by all the other pages. We want to maybe decide that before you go to this page, we want to insert another page. Yes? Well, this becomes a maintenance nightmare, right? I have to go and update all the incoming, right, pages that go into B, right? It's just a nightmare to maintain it. So a solution for this was to decouple these pages and say no. Let's remove the dependencies here, right? No page is going to depend on any other page, right? So what we're going to do instead is going to create a centralized controller in the middle that is the sole responsible for knowing who goes where. Okay. So what we're going to do is going to centralize this, and now maintaining this is going to be so much simpler. There will be one single point of maintenance. Yes. Perhaps an XML file, right? Some XML file, or maybe a JSON file. Even perhaps maybe have a GUI, a graphical user interface that can open this up and parse it, and interpret for me, and just draw the flow of the application. I can drag it around. I can draw arrows, right? And then I can write it back into this file. And now pages, instead of knowing about each other, they notify the controller, right? If you click on the login button, or if you click on the register button, or whatever, right? We never actually go there. We always notify the controller. We notify the controller of what the intention is, right? Some event that uniquely identifies the action, right? And then the controller can look up the action. Perhaps the action is that I want to log in, right? Or the action is that I want to register, right? The controller looks it up and says, yes, you trying to log in? All right, so if you log in, then this is what should happen. You try to register, this is what should happen. You try to view your profile, this is what should happen. You have a lookup table that you can configure and controls what should display next. Make sense? All right, so we've decoupled the pages from each other, making it so much easier to maintain. So that's exactly what we're going to do with Angular. Angular has a module called the routing module that allows you to configure these navigations, right? And based on hashes that are added to the URL, right? It's going to listen for changes that appear after the hash. So the URL is going to be something index.html. That's the only page we're ever going to load. That's the only page we're ever going to load, right? And what we're going to do is that we're going to use hash. We're going to make changes after the hash, after the index page. It's the only page that we load, and then we have just hash and something that follows. Angular listens for those changes after the hash sign, right? And depending on that hash sign, it will load certain snippets of HTML. Okay, the hash sign has been around for quite a while. It was very popular, well, still is, for creating links into the same page, right? Where you could maybe create like a table of content at the top, right? And you could create a link to a page and then declare several sections in the page, right? Using an anchor, right? And then depending on which anchor you meant, you could refer to which anchor after the hash sign, and then the browser would just scroll down, right? It would just jump around in the same document, right? So what Angular does, and many of these model view control libraries do, is that they hack that feature of the browser. Okay? They say, the browser can listen for these hashes. Yes? Okay, I am going to take over that behavior, that browser behavior, and I'm going to build a whole infrastructure around that feature, that browser feature. Okay? And then they use all these libraries, these JavaScript libraries, say, hey browser, whenever you see that hash, notify me. Okay, because I want to do something, right? Yes?
Why was the browser initially designed to listen to those hashes?
Oh, so that you can jump.
Version that-
You can jump in the same page, right? You can declare several sections.
Okay, so
Right.
that's been a feature for
That has
for
been
a long time.
from ever, right? And one of the better, nice things about it is that it participates in the history of the browser. The browser remembers,
Okay.
right, that if you've jumped into several different places and you click back, it jumps back to whatever you used to, whatever hash was there before. So it remembers, it pushes every time you click on one of these, it pushes it down to a stack, right, of where you are, right, in the hash. So when you do it back, right, it pops the stack, right, it remembers where you were in the different hashes, right? So it participates very, very nicely in the forward, backwards history, right? And Angular takes this this feature and builds around it a whole navigation and routing mechanism, right, which is what we're going to be using today. Okay. So for this assignment, you're going to be replacing all the hard-coded links, right? All the hard-coded links that navigated to specific HTML files. You're going to replace those, right, with equivalent hashes, right? And so that way, if you click on those hyperlinks, what's going to happen is that this is going to change, right? After the hash, if you click on the register button, instead of now navigating to the register button, to the register page, instead, the browser is going to interpret that as, oh, you want to stay in the same page, right? But you just want to append. You want to append register at the end. Okay. With the browser, typically the native behavior is that it's going to look for an anchor. It's going to look for an anchor on the page whose ID or name is it? I don't forget if it's the name or the ID. Whose name is register, right? It's not going to find it because that's not what we're using it for, right? It's not going to find it. Instead, it's going to be interpreted, right, by the Angular framework, right? Who has a listener on the changes of the hash. Okay? So any changes on that hash, Angular is going to be notified, and Angular is going to say, okay, let me look up my config. Okay, it's going to say, okay, I'm looking at the config. Here's register. Okay, what does that, where should I go? The register page, the register.html page. Yes? And that's what's going to be injected into the index page. That make sense? Right? And we're gonna play around with this quite a bit today, so you should be fully confident by the end of the class. So to configure all this routing, we're gonna configure all that in this config.js file. In this config.js file, which is going to be living right next to the app.js file. Okay, and here's a snippet of what that configuration looks like. Right, a couple of things here. All JavaScript files that you're going to be writing in this class, they're all going to be embedded inside of an IFI, right, and an immediately invoked function expression, right, and it looks just like this. You have a function here. Okay, that has no name, right? So it's an anonymous function that immediately is invoked. See this double parentheses, right? Open and close parentheses. The way JavaScript interprets this is that when it gets here, it says, this is an invocation operator, meaning the way it's interpreted is that I should invoke whatever is to my left, right? So there better be a function to my left, and indeed there is. Yes, there's a function that executes. And what does that function do? It does this here, right? Whatever it does, it executes it inside of the function context. See that? That function context creates this as all variables. Anything that is declared here is local variables, right? Local to that function. So anything that is declared inside of that function is opaque to the outside world, right? It's not littering the namespace. Right? It's only these are all local variables, right? They're not overriding any functions outside. They're not overriding any variables that are declared outside. We don't want to compete with any other libraries that might be declaring other variables, other functions in the global space. So in here we have an Angular.module that is reading a particular module that presumably has been previously declared, right? And declaring a function that is going to be used for configuring all the navigation. It looks something like this, and we'll play around with it today. It says, what this says, if you see #/login, this is the URL of the template, HTML template, that should be displayed next. And you have quite a few of these, right? There's going to be one for login, one for register, one for profile, website list, website edit, all of them are going to be represented here. Yes?
Is it bad practice to break apart your anonymous function if it gets too large into multiple anonymous functions?
Oh, certainly, yes.
Bad practice?
No. If you have quite a few of these, right? Perhaps per feature, right? If we really would want to do it, we would declare one for the user, one for the website, one for the. You can split it up, right? If your feature set is fairly big, right? It's a good idea to break it up into several config files, right? Several routing files, right?
Several routing files, not multiple pieces of functionality within one file.
Say again?
You mentioned several routing files, so breaking apart your functionality into multiple files.
Yep.
And within each of those files, is the best practice to have only one function?
When you say function,
You have the anonymous function on the board.
Oh, having one of these?
Yeah.
No, it's better. It's best to break it up. Each a single function to have it in there.
Single function.
Preferably, yes.
Okay.
So typically, for instance, one of the things that you'll see that I'm asking you to do is declare several controllers in a single file. When it's something trivial like what we're doing here, it's fine. But in a real application, what you would do is you would split up and have controllers independently declared in its own file. Okay. Actually, you know what I'm going to do? I'm going to rewrite this and ask to have separate controllers. I think I asked you to put it all into a single file. I'm going to make a requirement to split them up into different JS files. It's a better best practice. It's a better practice. Okay. Yep. So the routing that we're going to be declaring here, login and register and whatnot, are listed all here. Okay, in this page over here, right? And what HTML should display for which route. Okay. If it sees login or slash, meaning this, if it doesn't see anything, if there's nothing after the hash, the very first thing that the user should see is the login page. Or by default, meaning if they type some weird things that is not registered here, is not configured, so by default you would see the login page. So if you type something bogus, you will see the login page. Okay. If you see register, then you have the register page, and then if you see user and a user ID, then you would see the profile for that particular user. User ID website, you would see all the websites, right? And notice these are getting longer and longer and longer, right? And notice that some of these have these colons in front of them. You see that? Right? That means that these are placeholders, right? Meaning it's user followed by something, right? Presumably some ID that uniquely identifies a user, right? This one is a user some ID, right, followed by a website literal, right? So user and website are literals, yes? Whereas the UID here is a placeholder. Anything could be in there. And the way we're going to interpret that is that these are going to be all the websites for this particular user. If instead you give me a particular user, and then you give me the particular ID of a particular website, then it means that you want that particular website, not all of them. Yes? Right? And so on and so forth. So if you identify a pattern here, is because there is a pattern. It's following a pattern that we'll look a little later, but this is heavily based on what the RESTful APIs do. Right? RESTful APIs allow you to map a data space, right, to a particular URL syntax. Okay. So for instance, our particular data space has the following structure. Our data space has the following structure. You have a user, that has a one-to-many relationship with websites, right? One user can create many websites. Each website has a one-to-many relationship with pages. One website can have many pages. One page has a relationship with many widgets. Yes? So there's lots of these one-to-many, 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 right? So if you want to actually implement this, you can have maybe several users. Yes, in users, U1, user 1, user 2, 3, and so forth. U1, U2, U3, U4. Giving a particular user, you branch off and you go on to several websites, right? Several websites. So these are the websites for that user. If you choose a particular website, then you can go off to many pages. Right? These are all the pages. If you choose a particular page, again, it might be several widgets. Widgets, yes? So you have this tree that you have kind of like the root over here, and then it just branches off all the way down to the leaves. Yes? And we would like to be able to navigate all the data points in this tree, correct? So our URLs, right, the syntax of a URL should allow us, right, to place us anywhere in our data space, correct? Right? And notice that, indeed, we can start off by any user, right? We can choose any of these users to start off. Then we can go in and then choose a particular website, then go in and choose a particular page, and then choose all the particular widget within there. You see that? So RESTful APIs, as we'll see a little later, is a particular style, right, of organizing of the structure of a URL to expose data that is being hosted by some backend service, right? I am basing this URL structure based on that idea, which we'll introduce when we get to web servers in a week or so. Okay, all right. So this allows us this URL structure allows us to navigate anywhere in the website, and so the URL has the following interpretation. The URL has the following interpretation. If you have just /user and you don't specify which one, right? The general interpretation is that you must mean, since you're not telling me which one specifically, you must mean all of them. Okay? You must mean all the users. Now, should a normal user be able to list all the users? Probably not. Perhaps only the administrator, yes? Maybe that's a use case for the administrator. The administrator, it makes sense that they are looking at a list of users, right? We're not implementing the administrator, so I don't have the URL here for /user. There is no page of user list, okay? Right? A little later when we see security, that'll be part of your assignment will be, yes, add a /user that lists all the users, but only an admin should be able to navigate to that page, right? So you have to log in. If you're an admin role, then yes, you can navigate to the /user, and you can see all the users. Okay, but for now we don't have that. We do have /user 1, 2, 3. That's a perfectly that's a URL that maps to this, right? /users :UID. Since you're giving me a particular UID, you must mean that one user. Yes? And notice that maps to what? A profile view client. See that? I am looking at the profile of that particular user with that ID. Makes sense. It maps to that page. I can see that user's username, first name, last name, email, right? My profile, right? Once I've logged in. If you keep going and you say user and then user ID /website, since I'm not specifying which website, the only interpretation is that you must mean all the websites. But not all the websites as in, literally all the websites, right? It's the websites that belong to the context coming right for me, right? The context is user 1, 2, 3, and this website can only be interpreted as all the websites of user 1, 2, 3. Yes? Make sense? So that's why user UID website, right, is mapped to website list view client.html. See that? Okay. If you specify an ID for a website, 234, right? That's this one over here. If you specify a particular user ID, then that means that must be interpreted as in, oh, it's a website that already exists and has the ID 234, right? So that one is mapped to a website edit.view.client.html, right? Meaning I want to edit something that already exists, right? Let me go to the server, retrieve that from the database, I display it in the form so you can change the name or the description or whatever. Yes? Makes sense? If I want to create a brand new one, I have a keyword here, right? A reserved ID. That if I say if the ID is new, you must mean that you're going to want to create a new instance of a website, right? You don't know the ID. There is no ID because the website doesn't exist, and that's mapped to the HTML website new.view.client.html, right? And following that pattern, we have a list of all the pages for a particular website, a particular page for editing, for a particular page ID, or being able to create a brand new page, yes? And widgets, and the same thing for all of these. Make sense? Awesome. All right, so in index page, you'll then be asked to implement this routing mechanism. You'll be asked to load this Angular module, the routing module. Angular, when it used to be small, it was only just one single file. As it grew and it became more popular and it grew in features, it was split up into different little modules that you need to load independently, separately. And here, this is one of them. This is one of the more popular libraries, Angular route.min.js. If you're familiar with UI routing, that's a very popular routing alternative library that works well with Angular. Right? If you're familiar with it, you're free to use that instead. Okay, that's okay. But we won't be doing anything that is specific to the UI routing library. So Angular route is just fine. You load all the configuration. So from within index.html, you're going to have to load that new library, load the new config file you just created here, right? And you're going to declare a snippet of HTML in the index page. You're going to tell it where should it inject all this content, all this dynamic content. As it loads login page, where should it put it in the index page, right? And to do that, we're going to declare an empty div. It'll be a completely empty div with this attribute ngView. That's an Angular attribute, custom attribute called directives. That you're telling it where to inject all this content. Okay. You're then going to create the several services that are going to be responsible for holding all the data, right? For all the user data, all the websites, the list of websites, the list of pages, the list of widgets. It needs to live somewhere. Ideally, this would live on the server, all right? But we don't have RESTful APIs just yet. So for now, they're going to live on the client in a JavaScript file, okay? And the data, alongside with an API that would allow us to manipulate that data, right? All these types of data, they're all going to have very similar APIs, right? They should all allow us to create an instance, should allow us to find all the instances, right? Or find them by some criteria, right? If it's a user, maybe we want to find them by username and password, perhaps. That's a criteria, right? So create, find. We'd like to be able to update an existing instance, right? We'd like to be able to remove an existing instance, right? So the basic CRUD operations for every single data type. So we'll have CRUD operators for the user, CRUD operators for the website, CRUD operators for the page, and CRUD operations for the widget. Yes? Right? And here we give you some dummy pieces of data to get started with for a list of users. you'll notice that some attributes are missing, like email is missing. Okay? If you see any discrepancy with the user interface that you have built so far, that you're missing an attribute, feel free to fill in that attribute, right, with emails and description and titles, or if you see a missing attribute, go ahead and put it in, all right? And here are the CROT operations that we're asking you to implement. We have the create, certainly we have the update and the delete, but then you have a couple of different finders, right? Finders, they all start with find, and then the criteria, find, by, whatever, right? In this case, you can find a user if you know their ID, right? If you know their username, if they know their credential, username and password, and depending on your data type, you might create several finders, right? Maybe you want to find an employee by the date they were employed, or you want to find employees by salary range, right? Or whatever criteria you need, you would create a finder, right? That would allow you to retrieve data with that particular criteria. And obviously the function signature would take arguments that you need to fulfill that search. Okay. All the other ones, such as create user, typically take, they're very object oriented. Create user takes an object user, right? Find user by ID, presumably, right? If you give it, the ID, you pass it in. Update user, presumably, you take the ID of the user you're trying to modify, and then all new data that you want to modify for that particular instance. And then delete user is presumably you uniquely identify users. So all this is going to be implemented in a file called user.service.client.js. Okay. Again, notice the name, right? The first is the type, the data type, right, or the entity that you're manipulating. Then followed by the role, right? The service is the role of this file is that it's a service. It provides data. Typically, these are singletons, right? Single instances that are meant to be used everywhere across the application. If you have a reference to this user service, you have access to the data. Okay, so a single point of access to data. Then notice that it says client. That means that this provides data on the client side, right? When we get to web services, we will have a sister file to this that will be called, very similar, it will be called user service server.js, okay? This one over here, the client version, is going to be responsible for sending HTTP requests to the server, saying, hey, I need these websites. It'll do a get. Right, it'll do an HTTP get to the server, and the server, the server equivalent to this, is going to receive the HTTP request, right? And it's going to do a database lookup, and it's going to respond with a JSON array, right? And this guy, the client side, is going to be, it's going to be waiting for this to come back, right? And when it comes back, it can then provide the data to the rest of the client. Yes. For this assignment, we're only going to work on the client side. Yes, we're not going to have the server just yet. That's the next assignment. So for now, we're going to mock the data. All this data is just going to be hard coded on this client, on this service, user service. Right? It's dynamic in the sense that we are going to be able to add and remove and update. But if you refresh the page, all the changes are gone. Yes.
Can you describe the single point of access principle once more? You said
right. So, yeah, exactly. So one usual problem with accessing data on client side or even server side applications is that developers tend to come to a place in their application and says, I need a list of these things. It's in the database, and they'll write a query right there, a SQL query, and directly connect to the database, right, and receive the data, and then they'll just go on their merry way. Right? And if you keep doing this, you'll end up with SQL queries all over your code, right? And which will be extremely hard to maintain. A lot of these queries will be similar to one another, right? And so a better approach is to take all this access, right, and encapsulate it in a in a file or a class that is only dedicated for interacting with the database, right? And it provides this service to the rest of the application with a nice high-level API, right? That internally you have no idea how the data is being accessed, whether you know it's actual SQL, or maybe tomorrow you want to change it to NoSQL implementation, or maybe even a file access, or maybe a network access, right? Or instead of, or maybe it's XML or JSON or whatever, right? The API doesn't change, right? Everybody who depends on the data, you don't have to change that code, right? They are all accessing through this nice abstract API, right? And it's hiding the actual implementation of where the data actually comes from, right? So now you have decoupled, right? You have decoupled the data access from where it's being used. All right, that makes sense?
That does, yeah.
Yeah, thank you. So here's an example on creating a service. There's actually two ways. Somebody asked this on Piazza that you can use to create services. They're slightly different styles. You can either create singletons using the .factory call on Angular, or there is a .service that you can also use. This implementation, typically what you will find is a declaration of a map, right, at the top, at the very, very top, that declares an object of, oh, this is a mistake, this is an error, sorry. No quotes here. You have a map here. You have a map that is an object that says, these are the names of the attribute, and they're mapped to these instances of functions that refer to functions that are implemented down here, okay? And these functions are the ones who actually implement the creation or the lookup, right? And then whoever has this instance of this object has access to all these functions over here, right? There's another style of using service that uses the new operator, uses this as a constructor, right? And then you bind all these functions to the instance of that object, right? They're both singleton. They're slightly different styles, but they accomplish the same functionality. I believe some of you have gone the service route, right? And some of you have gone the factory. Either one, I'm fine with. Okay. In this case, we're going to be hosting the data in the service, right? Since we don't have a server yet, we don't have web services just yet. We don't have an API. For now, the data is going to be hosted right here. Okay. This is going to go away in the next assignment, right? Instead, this data is going to live on the server side, and eventually it'll live in the database. Okay. But for now, it's going to live right here on the service. The create is going to do an insert into this array. A finders is going to do an iteration over the user direct array, looking for things, right? Eventually, all these are not going to be. They're not going to have a local array, right? In the next assignment, this is going to go away. Instead, they're going to do an HTTP request to the server, all right? And that we'll do later on in the next assignment. But this is a snippet that gives you an idea of where to get started with implementing services. And the idea is that basically we're using the Angular infrastructure to declare this singleton and bind it to this string, right? And now the server is available to anybody who wants it just by naming, right, the name of the servers they want. Okay, very similar like what you can do in Java or .NET, right, where you can use annotations, right, with Java beans, right, that you can just say @ and then the name of the bean, right, and then the infrastructure instantiates that bean for you and just gets injected into you. So by the time your file gets instantiated, all those variables are bound to some other instance, right? So this is very, very similar to that. Here's the declaration side, right? This is something you would probably do in a in a bean.xml that you're declaring all the beans and whatnot. Okay. You'll do the same thing for website services, right? You create a website service. All these inside of a directory called services, right? It'll be a directory. Did I say that here somewhere? I must have somewhere. All these services are going to be under a services directory, okay, available to anybody who wants data. So website service, this is some dummy data for the websites. Notice that they all have a unique identifier of the website, and they also have somewhat like a foreign key, right, of who the developer is, who built this, right? So these are references or can be used as references to these users, these developers that were declared earlier. Notice that we have 4 developers: 1, 2, 3, 2, 3, 4, 3, 4, 5. Notice that all the IDs are marked as underscore ID. This is because later on when we get to MongoDB, MongoDB uses for unique identifiers uses underscore ID, right? So that the code that you write today, we can reuse it later on when we add MongoDB to this, right? And this will be actual data coming from MongoDB, right? And the data that comes from MongoDB, it'll look very, very similar to what we have right now, okay? So here's websites. These are unique identifiers for the websites, the names, a description, and these are our IDs. So presumably, user 456 created these 3 websites. User 1, 2, 3 declared these 2, and 2, 3, 4 declared just 1. And here are the CRUD operations, right? Create a website for a particular user ID, right? Create a website for that particular user. Update that particular website. I only need the ID of the website to update or remove. And 2 finder methods. One that finds all the websites for a particular user, or finds a website if I know the ID of the website. Okay. Pages is very similar. Widgets is very similar. Widgets, it's the only difference is that the objects that describe a widget are a little more involved. All right. You have the IDs. Different types of widgets, right? Whether they're headers, they're images, YouTube, HTML. You have the page that they belong to, right? So these are kind of like foreign keys referring to the page they're inside of, and some attributes that are specific to that type of widget, right? So if it's a header, I want to know the size and the text. But if I'm an image, I don't care for size, right? I care for maybe width, right? So the schema of these widgets is kind of elastic, right? Each widget is going to have a different schema, right? Which would be ludicrous in a SQL database, right? Where you have different, each record having different schema. No such thing. In a NoSQL database, that's totally fine, right? Each instance could have a completely different schema. We'll talk about that later in the pros and cons of that when we get to MongoDB. But you'll notice that each one of these widgets has a slightly different schema, right? That is interpreted by the type of the schema. Yes? For the widget service, we have the CRUD operator, same thing: create, update, delete, and 2 finders, right? Then for each one of the views, the login view, the register view, we don't call them pages anymore. We call them views now. For each one of these views, you'll have a dedicated controller, right, which will be responsible for interpreting all the events, the stream of events that the user generates as they interact with the view, and converting those into real actions, right? Through the service, either finding users or creating new users or deleting users or updating users, and then providing the view with the resulting data, right? And then the view then re-updates with a change in the model. The controller sits in between the view and the model, right? Converting between these 2 worlds, right? Converting between the messy human world, right, and the more structured, and a world of objects, right? And does this conversion between these two worlds. Okay, you'll find this a lot in multi-tiered applications, right? Where you have lots of these different. That's why they call multi-tiers, right? And you have a lot of layers, right? And a conversion layer between them. How do I convert between clicks and drags and scrolls and typing, right, into the object world? And then convert that into something on the cloud that I have to send over. And so you have to convert between the object world and the stream world of HTTP, right? Network zeros and ones. And then on the other side, you have to reparse all the headers and cookies and all that back into the object world, right? And then inside of a MySQL SQL database, right? So you have all these layers that you need to convert between, right? There's lots and lots of that. So here's what I'm saying, that instead of creating a controller, my original intent is to have the 3 controllers for the user, right? For the 3 views listed in one single controller file. All right. That's actually not a good practice. A better practice is to have each view for a particular controller for a particular view. Right, so something like this. You would have under the user, you would have something like the login controller. You would have the register controller, and you would have the profile controller. Okay. Same thing for website. You would have the website list controller. You have the website edit controller, and the website new controller. Okay. I'll update the other ones later. That makes sense, right? Some folks will go a little further and notice that under the user directory, you will also have the 3 HTML files under there, right? So some folks might even prefer to create this a little bit deeper and have a couple more directories under here, and have the HTML under templates, right? All the HTML would be under here, right? And all the controllers would be under controller. So this would be templates, and then controllers under here, right? I'll leave that up to you if you want to go that deep, right? I think for what we're building, it would be a little bit over-engineered, I mean, you could re-engineer. You could do lots and lots of over-engineering on this. I mean, right now we're only using 3 layers on the client: the view, the controller, and the service. But you can certainly put more layers. You could put a model in there too. Okay, that does conversion between data types that are coming from the server, and reparse that and restructure the data that is convenient for consumption by the view, right? You might put a couple of layers there if you're doing something like an aggregation site, right? Where you're trying to aggregate prices from one website and prices from another website, and you have to convert between data types that are coming back from one website, convert data types from another website, unify that, right, into a unified model, right, and then do all your aggregation, right? So again, you can over-engineer this quite a bit, all right? So I'll leave this as an optional. Right, if you want to go that further, controllers, and this would be all the controller in here. I'll leave this as optional. Okay, but it would be totally fine. All right. All right. For the controllers, each one of these controllers will look something like this. Right, you'll have for the web app maker module, you'll create a controller, right? The login controller declared here by name, and then the declaration of the function right here, login controller. This is if you're putting 2 or 3 controllers in a single file, which we are, at least that we're doing, right? So I'm going to remove that. Each of these controllers will look something like this, right? So it'll be login controller, and there it is. And then each one of these will be in separate files. Yes? Okay. And here's just a list of all the controllers. Well, no, not finally. We're only halfway. In the config file, you need to configure. You need to say that, hey, when this template loads, when this HTML is injected and is displayed, right? When the login page, when you navigate to the login page or the register page or the profile page, also the following controller should also load along with that, right? So that the view can display to the user, and the controller will be ready listening for gestures, human gestures, clicks and drags and whatnot, right? And can start asking for data from the service. Yes? So we need to load all those. And so you'll go into the config file, right? And for each one of the views, you will declare what controller goes with which view. Right? So when you navigate to hash login, not only are you going to display the login template, but you're also going to load the login control that goes along with that template. Make sense? Right? I'll explain model in a second. So there's a big discussion on whether we should use scope or not, right? On the and the examples I gave you the first week or two, we use scope, right? We use scope to bind data that the controller provided, so that it can then be displayed on the view. Correct? Right? Anything that you declare on the scope is now available on the view, right? And vice versa, right? If the view declared any variables, they would then be available through the scope on the controller. Make sense? Right? So this is the native way that we do this in Angular. But after implementing a few of this, you start to notice that that's actually not a great way of doing it, especially if you start having in large applications where you might have controllers nested inside of other controllers, nested inside of other controllers, right? When you have this kind of nesting, the scopes are also nested, right? Inner scopes inherit from larger scopes, right? And those scopes inherit from even larger scopes, yes? So you start having problems of clashes between things that might be declared at different scopes, right? Sometimes you don't know if this variable at what scope was it declared at, right? So one of the ways to deal with this is not to use scope at all. Instead, to bind the variables and the data onto the instance of the controller, the actual controller instance, right? Since there is no inheritance between the instances of the controllers, right? Unless you explicitly navigate to your parent somehow, right? There won't be this issue of asking yourself, whose variable is this, right? Who is responsible for giving me this variable, right? It will always be within the context of the instance of the controller, right? So to do that, we're going to be using the following design pattern. When you declare your controllers, you're going to be binding the controller instance to a local variable, okay? And then you're going to be binding any data and any function, right? You're going to be binding, instead of binding it to the scope, instead of doing $ scope here, right, which is what we did a couple weeks ago, right? Instead of binding things to the scope, we're going to bind it. So how can I strike this through? No scope. Strike through. So we're not going to have the scope. Instead, we're going to have the VM, right? Some local VM for view model, right? A data model for the view. So I can pass data to the view. So I can talk to the view. And then when you're configuring, we're going to say, hey, controller, when you're going to be bound to your view, this is the view that you're going to be responsible for. The view is going to be able to talk to you through this name, right? So within the view, instead of just being able to declare variables willy-nilly, you'll have to scope them. You have to say, oh, it's through model dot, and then the name of the variable, right? Okay, so these variables are no longer just going to be, magically appear. They're going to be bound to some scoped variable, right, or to some scope that has a specific name. All right. Again, we'll visit this a little later, but it is required in this class, for this assignment. So no longer are we going to be using just plain old user dot something. It's going to be scoped to the instance of the controller that has the name, whatever name you gave it here. Whatever name you gave it here. Okay? Again, we're going to do this today quite a bit. These are all the controllers, the different views, the form elements. Okay. I think we should start playing around and actually implement some of this, all right, just to illustrate, right, and then we can revisit this. Okay, let's start building something. Let me